Hey, is this thing on? Hello? Hello? Oh, okay. There you are. Hey, everybody. Um, I've heard that you have some questions about energy. So, I thought I might help you out. There are lots of kinds of energy, and hopefully you've come across some of those in your research. But, just to summarize, we've got mechanical energy and internal energy. Mechanical energy is mostly dealing with things like big things like springs. Yeah, okay, like this. Here you go. And flying things or moving things like that. Or things lifted up in a gravitational field. Definitely some, oh, there you are. Definitely some potential energy there, right? Right. Okay. So if an object is lifted up in a gravitational field, it definitely has a potential to make something happen, like me falling. Or back to our spring. If we squish a spring, it definitely has the potential to do something, like explode in my face. Or if we stretch it, it definitely has the potential to do something, like shoot a person or a frog or something. Sorry, lost my spring for a second. Hey, frog, come here. Frog will show you the potential energy in the spring. Good job, frog. Thanks for nothing. Anyway, yeah. And, okay, so there's gravitational potential energy and elastic potential energy in springs and things, and kinetic energy when things are moving. So it's important also that you recognize that energy goes from one form to another. So, for example, when I have gravitational potential energy, because I'm, there you are, because I'm lifted up in a gravitational field, at the bottom, I had a different kind of energy because my gravitational potential energy turned into, what was that? Yes, kinetic energy. Good job. Okay, so what about when frog, come here, frog. What about when frog was on the spring? Oh, easy, frog. When frog squishes down the spring has elastic potential energy. And when we let go, then his energy was converted to kinetic, right? Because he started moving. But at the very top of his flight, what kind of energy did he have? He had gravitational potential energy, just like I did when I was, there you are, when I was floating. So, pretty cool, huh? Yeah, I know. Okay. Thanks, frog. Get out of here. Also, you need to be familiar with the equations that describe these types of mechanical energy. I'll be right back. Okay, that's better. Thanks. So, first off, you need to know, well, give me a second. Okay. Okay. You there? Hello? Yeah, okay, we're back. So this right here is describing kinetic energy. E for energy, K for kinetic. The 1/2, yeah, that's 1/2. And M stands for mass, V stands for speed. And notice that it's squared, except for I kind of erased it a little bit. Okay, so kinetic energy is easily calculated by doing 1/2 times mass times the speed squared of the object. Okay, this one right here is elastic potential energy. E for energy, elast for elastic. Notice that's calculated by just doing 1/2 times K times X squared. K stands for how strong the spring is. X stands for how much the spring has been stretched or squished from its normal length. Okay, it's not the length of the spring. It's how much it's been stretched or squished from its normal length. So 1/2 kx squared. That calculates elastic potential energy in a spring if it's been stretched or squished. Now down here, can you see that? Okay, down here we've got gravitational potential energy. So that's potential energy because something has been lifted up in a gravitational field. So E for energy, G, even though it looks kind of like a 6, that's a G for gravitational. This is easily calculated by just doing mass of the object times gravitational field strength, which for the Earth is 9.8 newtons per kilogram, times h, which is how high the object has been lifted. Okay, these are the 3 types of mechanical energy that we will work with in our class. I hope you love them, and I hope that the equations are not overwhelming and that you can learn to use them properly and have a wonderful experience. And if you have any questions, come find me. I'm usually sitting on the counter in the back of the room. Thanks.